So, good afternoon. I'd like to introduce our speaker for today, Michael Davison. Michael received his degree the same year I did. That was 19... he's had a long, long career. Some say too long. His first publication, the title of his first publication was Response Cost and the Control of Verbal Behavior under Free Operant Avoidance Schedules. Now, right away, this tells you that, from what we know subsequently, Michael had no problem at response cost and the control of verbal behavior. He's published 150 articles, many of them in SQAB, 4 in the last year alone. Going strong. Yeah, indeed. And so it was so very hard for me to pick amongst these to capitulate which ones I liked best. There were so many of them. And since I only have introduction to do, I'm just going to have to go with the titles. Some of the titles are amazing. Some are sort of standard academic titles. Some put real meat on your bones. Time versus response indices, well, that's classic. Feeding a mixture of complex lipids derived from milk to young rats results in improved parameters. Well, I always wondered how he got such good parameters in his state of function. And so it's the lipids. You know what you have to do now. Now, he also has other hobbies, and you probably didn't know that he has a large herd of sheep. And to keep the cows off his territory, he experimented with some troughs. And he actually published a paper with this title, Effects of Providing a Water Trough on Stream Use by Beef Cattle Grazing in Hill Country. You didn't know this about Michael. He's a many-talented person. Some of these...
Many talented.
Some of these publications have recondite titles, behavior-centric versus reinforcer-centric descriptions of behavior. Some are pure poetry. Variance matters, the shape of a datum. Isn't that beautiful? Shape of a datum. I've been arguing with Greg Fetterman over whether pigeons really count at all or it's all timing. And I should have known I'd be scooped by a more salient question. Do conditioned reinforcers count? I never thought of that. But I should have, because something that was even more mind-boggling came before with he and Billy, where they asserted that every reinforcer counts. Now, this is almost like quantum mechanics. If you understand it, you don't understand it. But we have it from highest sources that these things also count. Some of Michael's titles are wistful, sad titles, leaving patches. That's a heartbreaker. Some are pensive thoughts, like a view from the laboratory. Others are alliterative, concomitants, categories, and constraints, and others are afterthoughts, dignified by further analysis. That's a good paper. You should check that out. So amongst these titles, one more. There was a biopic. I'm sorry, Michael. There's a biopic on how he found Skinner. These are all his titles. Foraging for a Science of Behavior. Remember that one?
Yes.
Yeah. Or poignant life decisions that he was faced with and had to make. Buying cars and being a scientist. The rough one. And then recognition that he'd missed an opportunity to do things right, important life decisions. Don't even consider buying the old model when the new car is in the showroom. We know what the other title did for him. But today, this is not an encomium. I wouldn't be starting out this way. This is a tutorial. You're all here to be tutored. And not only are you to be tutored, it's not just an ordinary tutorial. This is a preeminent tutorial. Now, you know what a preeminent tutorial means. It's for people to come before they're eminent and get tutored. And if you come here and listen to this man, and you are preeminent, you will become eminent. But, yin and yang, dark side of force, bright side of force. If you're here and you're eminent already, you're going to become preeminent. I'm sorry. That's what these tutorials are for. Maria has arranged it. But seriously now, folks, I want to preview a couple of the things that Mike was going to do. And then you can sit down. Key terms: ovas, pies, and reinforcers. These guys are rewriting the book on reinforcement. And at first I was shocked and outraged by it. Then I thought, why didn't I get there before them? Reinforcement means strengthening. And this is what I've always thought about for reinforcement. And Billy and Michael have been pretty persuasive lately in talking about this really isn't all it seems. It's really something else. The event's the same as we were thinking about, but the way you talk about it makes all of the difference in the world. Billy and Michael talked about pies, phylogenetically important events, which is another way of saying things that will often function as what we think of as reinforcers, and they're important for obvious reasons. I actually like Michael's ovas, if that's what it still is, a little better, organismically valuable activities, because it doesn't predispose you to thinking they're hardwired or that you can't get them conditioned. But all of these are key terms, and it's a key reconstruction of what reinforcement does for us. This is a tutorial, so hopefully there's a lot of ABBA people in here, and you want to go away with something that will change your life in useful ways. I think this talk will do it, because he's telling you how to think differently about reinforcer. And because that in itself is pointing its way as a signpost to good new activities, Michael, in what he's going to be talking today, is going to be a potent reinforcer for your behaviors. So pay careful attention, formulate arguments he can answer. We'll leave time for some questions.
There is a slight problem here today. And it is that I'm going to give this talk in English, and we were going to have a simultaneous translation available, but the person hasn't arrived. So for those of you who don't speak English, speak American instead, you're just going to have to sort of try your best. And if I say schedule, you can all say boo at that point. Okay. It was in 2001 that I talked, to the day probably, that I talked under the title, What Reinforcers Do to Behavior. There was no quotes in 2001. So what it is today is what reinforcers do to behavior. 2 signposts to the future. The first one was not 1, because I never thought that I was going to change my view about what I would think about these things, but I did change my view. Thanks, by the way, to Doug Elliff, who I have coffee with every morning, and we talk about these things. But there's another alternative title, and that's Operant Conditioning, It's Not What You Think It Is. And that's just a slight modification of Rescorla's 1988 paper title, which was Associative Conditioning, It's Not What You Think It Is. So I thought I'd use that as an alternative title. It sums up perhaps what I'm going to try and say. I am somewhat diffident, of course, about talking about reinforcement and this august convention. But, you know, what the hell? It's got to be said, and if it's just seen as variation, which you can then select, that is fine. You can ignore the whole thing. But I think you should do that at your peril, because I think things are changing. Well, Billy and I are changing anyway. And that's things. So there are a couple of bullet points, 3 really, that I want to start off with. What I really want to say is that reinforcers, in quotes again, I have trouble with this because I don't know really what to say. Billy's got a different word. If you go to his talk, which I strongly recommend, he'll be saying similar sorts of things, but not the same things, later on in the convention. Reinforcers are valuable events, and both these and, quote, conditional reinforcers, unquote, are discriminative stimuli that control future contingencies that may be constant, I'm going to call this extended control, or may vary systematically with time since the onset of the event, and that will be local control. I'm going to say that neither reinforcement nor conditional reinforcement inherently increase the probability of responses or activities that they follow. And I'm going to say that, and this is the dynamical part of the thing, choice, behavior change, produces differential contingencies over time, and differential contingencies over time also control choice. So we have a chicken and egg a dynamical chicken and egg problem that we're going to have to deal with. And sometimes things that look like reinforcers are not going to be reinforcers because the animal came into the situation with that behavior and caused a difference in the contingencies after a piece of behavior. So we've got a dynamical relation, and the final stable state of what we do when we reinforce something, it may well depend on the initial conditions. I looked at scienceofbehavior.com to see what everybody thought about reinforcement at the present time, and I edited it for punctuation and grammar, what it is for most people, and it's a very reasonable thing, and I'm not going to say that this is not quite a reasonable way to think about it, a process in which a behavior is strengthened, i.e. the behavior's frequency, rate, duration, intensity, or other dimensions increase or persist as a function of an event that occurs as a consequence or contingent on the response. Reinforcement may occur naturally or be planned. It is defined solely by its function of increasing or maintaining behavior. Two basic reinforcement procedures are discussed in this book. It wasn't a book, it was online, but I don't know. Positive reinforcement, negative reinforcement, both increase or maintain behavior. Well, I shall assert that reinforcers are events that signal future contingencies of reinforcement and that they are stimulus events. And if you go along with me when I say that, and well, just stick with me for a while, then we're going to have to start thinking about research on stimulus control, because really underneath I'm saying stimulus control is the thing we have to understand rather than reinforcement control. And that's a complete about face, really, from what I would have said 9 years ago in 2001. We've got to understand it through an understanding of stimulus control. So first of all, I just want to go across a couple of findings that we've made recently, which support the idea of, first of all, conditional reinforcers as signals, as stimuli, as discriminative stimuli. Billy and I have published 2 papers, 2006 and this year, 2010, in which we've gone to some lengths to try and show that conditional reinforcers don't always increase behavior, sometimes they decrease behavior. In this research, we've been using concurrent VI food schedules, and it's a frequently changing procedure. So the values of the reinforcer ratios, that is, the values of the how many reinforcers you get here, foods we can say you get here, foods here, change from time to time. In fact, about every 10 foods or 20 events or something like that, they change, they move around. So the animal has to adapt. The animal has to adapt to changing contingencies of reinforcement all the time. Now, in this research, both of these papers, we've also put in stimulus events as well. That is, just green key lights, things like that. In the 2006 one, we used magazine light and green key lights, so on and so forth. And these are response contingent as well. So there's food that's response contingent, and there's stimuli that are response contingent. Now, slight difficult graph here, I suppose. The first thing is that, now which was the pointer? The top one. Yes. Oh, the other pointer was better, wasn't it? You got the other one? First of all, the top one is foods. And what I'm showing you here is what are called preference pulses after food delivery. And there's preference pulses on the left. What do I press here? Oh, that little button there. These ones up here are preference pulses after left foods. That is, briefly, after a food, there's a very strong preference to the alternative that just provided the food. Here. 0 is no preference. That is a very strong preference. This is a log to the base 10 axis. So, 20 to 1 here, and it falls down like that. Now, X here at the bottom, right at the bottom, is 1 food delivery, 2 food deliveries, 3 successive food deliveries, 4, always in order. So as you go through, 1 left, 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 and so on, or right, 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 and so on and so forth. So what happens, you can see very clearly, is that after a food delivery on the left for left responding, or a food delivery from right responding, you get preference pulses. And, we've always thought to ourselves, well, this looks like the sort of, real reinforcement effect. Suddenly the behavior shoots up and then it falls down again following a reinforcer. Well, green key lights. Now, in this particular set of data here, and I'll show you another set in a minute which is different, in this particular set of data, they're also getting green key signals, response contingent again, and they occurred in the same ratio as the foods. Right? So if the foods were 27:1 between the two keys, the green key lights were 27:1 between the two keys. And you see much the same thing. Now, first thing, just see that this axis is not as wide, as long as this axis here. This goes from 2 to -2, this goes from 1 to -1. So these are smaller, but you can see exactly the same effects. After a left, 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 and so on and so forth, you've got the same effects occurring, and so what you've got is something that, would be a putative, I never can say that word properly, conditional reinforcer, okay? And so green key lights, especially when there's been a lot of them before, are producing a big change to, if it was a left green key light, to the left key, and so on and so forth. So, both of these sort of move out like that in the same kind of way. They come further apart as you get more and more of them in sequence. Now, a slightly different one, different condition of the experiment. In this condition, the ratio of green key lights that you get on the two keys is exactly the opposite to the ratio of foods that you get on the two keys. And you can see, well, immediately you think, oh yes, they're doing the same sort of thing, but then you suddenly realize that now the open circles are above the closed circles. These haven't changed. What happens after a food hasn't changed, but after a green key light, it has changed. When I get a left green key light, I'm going right. When I get a right green key light, I'm going left. Now, I wouldn't bother you with this really, but actually the green key lights in this condition were paired with food, right? They were paired with food, so they should have been conditional reinforcers, but they're acting as, well, conditional punishers, you might say, aren't they? They're decreasing the choice of something. After you get it, you're going over the other side. So they're doing something quite different. They're not acting as conditional reinforcers. So this kind of thing makes us think that there is something going on here about what the stimuli are signaling. Because when you get, in this particular condition, you get a green key on the left, it means there's more on the right. If you get a green key on the right, it means there's more on the left. In the previous one, green key on the left, more on the left. Green key on the right, more on the right. So, it looks like conditional reinforcers are kind of signals for what's coming up rather than anything else. In another experiment, which we published in 2005, done by my PhD student Chris Cragalow, we looked at food reinforcers. And in this experiment, we had sort of a concurrent VI schedule, the standard sort of choice procedure, except for one little nuance, and that is we manipulated the conditional probabilities of foods given foods at an alternative. So, for example, in one condition, this is only some of the conditions here, in one condition, the conditional probability of food given food might be 0.9. So if I get a food on the left key for pecking the left key, then I'm likely 0.9 to get another one on the left key, but 0.1 to get one on the right key. Okay, so this gives long runs of food deliveries and so on and so forth. Alternatively, if the conditional probability was low, then if I get a food on the left, the next one is more likely to be on the right. If I get one on the right, it's more likely to be on the left. So, it's just a kind of, sort of a concurrent VI, but we're manipulating, well, the runs, I suppose, or something like that. So, what happens? Well, probability of 0.9, conditional probability of 0.9, you get long runs. So, what you get here, following a left food, you get a nice left pulse. suddenly, the animal shows a big choice for left immediately after the food. This is responses after the food, lasts about 10 responses, something like that. Looks like the usual sort of reinforcement effect. On the right, same kind of thing. Here's the food, and there's a big pulse to the right after it gets the right food. Okay, very straightforward. But when the conditional probability is low, actually we have here p equals 0, we did 0.1, 0.3, all that kind of stuff. But when it's 0, when a food does not signal another food, in fact a food here signals food there, you get something quite different. You can see that in fact after a left food they tend to go right, that's below here. This is a leftover right, so they're down here. After a right food they tend more or less to go left. Okay? So, in this case, reinforcers have not increased the probability of responses that they follow. What they've done is signaled to the animal, this is what you should do in the future. Okay, so in both cases I'm saying that what's going on is that food and signals for food either increase or decrease behavior depending on what they signal, what contingencies they signal. They don't increase or decrease behavior in a natural sort of way. So a particular sort of event, like food, may act to either increase or decrease behavior depending on what the food signals. They're either definitional punishers or definitional reinforcers. So, what animals do, reinforcers do to behavior depends on what they signal for the future. They signal more future food for this activity or more future food for that activity. And you could say, and I will, more phylogenetically important events, and that's what Billy Baum calls them. We're trying to get away from the term reinforcer because it has all this baggage that comes with it, doesn't it? I slightly prefer the organismically valuable activities or something, a sort of pre-Machian kind of thing. But, I don't particularly want to be asked the question, well, where do they come from and why and things like this. I'll take Skinner's thing there. I don't care. I don't care where they come from. They come. Now, what's been going on? We've known about reinforcement since 1897 or so. Why have we missed these effects? Well, we actually haven't missed these effects. But what we have done is seen them on many occasions and taken these sorts of effects that I'm talking about, the signaling effects, as epicycles to the effects of reinforcement. We've said they are also discriminative. They are reinforcers, but they're also discriminative. They also have discriminative properties. We haven't given really much attention to alternation or to the discriminative properties of organismically valuable events. We haven't really said, well, FI performance is a bit funny, really. Why doesn't it do it immediately after the reinforcer? We haven't taken much notice of priming the ratio and things like that, where these sorts of things go on. We've said, no, it's an epicycle. And also, in every typical experiment, really, that we've done, foods, I'll say foods just a minute. Foods have signaled more foods. They don't signal fewer foods. They normally signal more foods. So we've just sort of avoided a kind of area, a kind of domain in which these things happened. And if we see them happen, we try to say they're epicycles. So practitioners, of course, people out there in the big wide world doing useful things, unlike ourselves, are heavily into conditional reinforcement. I mean, clickers and things like that, are all the time used. But, surprisingly, if you go right the way back to 1961, thanks Tim Shahan for pointing this out, there's a nice little paper which demonstrates that the paired magazine click paired with food, and it's not necessarily a conditional reinforcer. It depends what it signals. So we've kind of known about these things for a while, although that's in a slightly different tradition. So I think we're wrong about reinforcement, and I'm going to try and convince you with some data in a minute. After we've just had a look at stimulus control, if I'm going to talk about these kinds of things, I really need to be interested in stimulus control by brief stimuli, because food presentation is generally a brief kind of event. And as you realize that most of our stuff that we've done in our area has not been brief stimulus control, it's been extended stimulus control. So stimulus control then is the modulation of responding during or following the presentation of a stimulus, I'm saying. And what it does is arise from different probabilities or frequencies of reinforcing events for activities in the present or following presence of or following the particular stimulus. It arises from differential reinforcement with respect to the prior or the current stimuli. Okay? What we've looked at when we've looked at multiple schedules is the sustained stimulus control, and we've understood generalization and discrimination and things like that. But also, I mean, interestingly enough, when we've been doing these studies of stimulus control on multiple schedules, we've occasionally found little problems. Sometimes people have found that if you have a fixed duration extinction component or something like that, you know, animals start responding a bit towards the end. You know, why do they do that? Well, nobody wanted to know why they did that. What they did was to put in a little resetting thing at the end there to stop it happening so that they could make their discrimination index just a little bit higher and a little bit better. So, you know, we've avoided these problems by little extra contingencies, adding these on, and so we've kind of buried them, and we shouldn't have buried them because they may be important. There's lots of little bits and pieces about reinforcement that may be important. But what that last example does is to bring to the fore the potential of control by elapsed time since a component start in the case of the multiple schedule, but since the reinforcer in the case of a reinforcer predicting something is going to happen in time. There's a huge area, of course, of timing research, which I cannot go into, and I'm not going to go into. But most timing research is nothing to do with time since a reinforcer. It's usually to do with time since an event. So it's not directly in my purview at the moment. There's been very little research on brief stimulus control. Associative conditioners, of course, use brief stimulus control all the time, but you know, possibly they're not looking at the stable state behavior. I don't know. But of the things that really matter, and this was important way back too, a lot of people demonstrated around 67, 71, Jack Ma sort of looked at it again in 79, in second order schedules, you don't have to pair the brief stimulus that ends each component with reinforcement. You can maintain behavior without doing that. Alan, you've called it a quasi-reinforcement, I think, at one time. Yeah. Those sorts of things, you know, kind of a worry, kind of a little worry, and maybe they're saying the same sorts of things. Maybe they're saying these stimuli signal things in the future. But the most important area, I think, is the area of conditional discrimination. I think that's important because, of course, Tony Nevin and myself, I saw him lurking at the back somewhere, there he is, you know, have been seriously involved in conditional discrimination for a long time, and that is an area in which we often use brief stimuli, and we can understand a little bit more about brief stimulus control from that area. What our research in this area, and our modelling in this area for that matter, has done is to give us a much better understanding of what differential reinforcement with respect to stimuli really means and how it can be quantified. And that is what provides the stimulus control here. Now, what I'm really saying here, and I just have to sort of add this very clearly, what I'm saying is that reinforcers are one discriminative stimulus that signals things that are going to get happening in time. But I'm also saying another discriminative stimulus is the time since the reinforcer. Both of those things are sources of stimulus control in the approach that I'm taking. Okay? And I think, one of the nice demonstrations done in 1996 by Jeff White and I can't remember who, Cooney, what was the demonstration that in the conditional discrimination you can say, okay, here's a stimulus, and if I ask you at 4 seconds, then the reinforcer ratio will be much towards this key. But if I ask you at 20 seconds, it'll be much towards that key. What will you do? Well, you're nicely controlled by it. You go this way, or if you ask at 20 seconds, you go that way. A very nice demonstration of control by time since the stimuli, in this case, just simple stimuli. So, if we're going to think of reinforcers then as stimulus events, albeit valuable events, what do we have to think about? We have to think about, do the stimuli, that's the reinforcers now, okay, do the stimuli signal differential contingencies? Do they signal something different for different activities in the future? If not, then we may not get a reinforcement or a punishment effect. Now, I've underlined may because you see a little bit later that I'm not sure whether this is going to happen or not. Are future organismically valuable activities differential with respect to the stimuli? Again, if they're not, then we may not get a reinforcement or a punishment effect. You see, you've got to tell the stimuli, you've got to tell the reinforcers, you've got to tell the contingencies. How discriminable are the signaling events? And this relates to some research I'm going to show you in a minute. Food for any response may be quite a discriminable event, but it may be more difficult for the animal to discriminate food for the left response and food for the right response. Again, I'll show you some data about this later. And the last thing, of course, is how well can the organism discriminate or be controlled by? How well can the behavior be controlled by the passage of time? And this is critical if contingencies change since events. Change, in this case, since reinforcers. In this case, after you've got a reinforcer, what does it say about where the reinforcers are going to be in the world following that? And that, of course, is a whole area of its own. And we probably think that, something like a constant coefficient of variation or something like that, so things get mushier as you go further out or something like that. But again, I don't want to get into that. That's Peter's thing. He has to do that. So, for stimulus control, then, we need detectable stimulus differences with respect to detectable differences in consequences during or following the stimulus differences. Now, this does not guarantee stimulus control. It simply allows it to develop. And that's an important point. You can make stimuli utterly discriminable, you can make the contingencies utterly different, and the animals, as you know damn well, will not pick this whole thing up. You have to talk to them a bit more. So it doesn't force stimulus control, it just allows it to develop. So there's all sorts of things, that people sort of talk about under this kind of thing. Hypothesis, superstition, pre-solution period, lab law, things like that. So the interim bottom line of this whole thing is that signals, reinforcers or stimuli will not gain discriminative control if future organismically valuable activities are not differential with respect to the signals. And that means they won't discriminate. They won't discriminate in the way that Tony Nevin and I wrote it in 1999. Nor will they gain control if the signals are indiscriminable, because then they can't discriminate. That's the way we put it again in 1999. But the important thing here is to stop and say, well, that's all very well and good, but that's a conclusion in statics. Because dynamically strong choice or frequent behavior or something like that can drive a reinforcer differential, and I'll show you that in a minute, can drive a reinforcer differential that is not there, that you have not put there. It can push one in and it can start responding to what it did by its own behavior. So you call that perhaps a type 2 superstition or something like that. So for example, what I'm saying, an animal enters a new situation with a particular sort of preference or more behavior here than there, that can drive a reinforcer differential, and that reinforcer differential will maintain that preference. by its own bootstraps. And me, Sheldon and Lobb in 1980 published a paper on that. Okay, preference pulses. I want to show you some preference pulses in a minute. They, at first blush, seem to be what reinforcement is about. You know, basically, it repeats the behavior that it just emitted, at least sometimes. Okay, so what happens then is if you get a preference pulse, what is going to happen to your payoff in the situation? You may have arranged two constant probability VI schedules on two alternatives. Constant probability, yeah, everything's going to be fine. But if the animal goes into those after a reinforcer with a huge preference, a preference pulse for one of the alternatives, it's going to drive the reinforcers to that alternative, right? So it's going to maintain itself in that kind of way. So what I'm saying is this, that it's possible that even though as an experimenter you've set up everything totally constant probabilities, everything like this, the animal will mess with your contingencies, do something to your contingencies, move the reinforcers around in time. As McLean and White talked about in 1983 when they were talking about modeling multiple schedules. The animals can move things back. It doesn't have to take that one now, it can take that one later. Here's an example, a reanalysis of a paper by L.F. Davison and Landon in 2008. Just a bit of the data, and an analysis that we did not do when we published this paper, naughty us. Naughty Douglas, really. What we've got is just concurrent VI schedules, did I say it right, with a changeover delay of 2 seconds. Changeover delays are dangerous when you think about it, because most people keep the changeover delay going after the reinforcer, and that means you can only get reinforcers on the same key in the 2 seconds or 3 seconds after a reinforcer. So that's going to do something. So look what happens. First of all, we've got nice preference pulses. That's the green one here. These are probability, relative frequency stuff here. It's a 9-to-1 food ratio, so the reinforcer ratio should be a here. The preference pulse goes down like that over something like 50 seconds. And look at the reinforcer. I mean, they're supposed to be going along there, but the preference has driven the reinforcers right up there. Hugely up there. Okay? So, while we thought, you know, everything would be fine, as experimenters we said it's going to go along there. It didn't go along there. The animal's behavior moved it. Equally down here is the 1 to 9. The behavior here, the green one, goes up like that. There's a preference pulse to the other alternative now, and the reinforcers do that. They come finally down to where they should be, but it takes a while to come down there. So, preference pulses then are largely held up by their own bootstraps. And what you'd expect, I think, in a general sort of way, sort of summarizing just this for a minute, is if the animal can discriminate the signaling stimuli and can discriminate the things that follow the discriminative stimuli, the reinforcers, right? If they can't discriminate, if they're poorly discriminable, the changes are going to be muted over time because it won't be able to see the difference. It'll just sort of say, well, this is generally what I get. But if you give them things that really do change after reinforcers, then their behavior will follow those things. If they discriminate the reinforcer, the signal, and if they discriminate what happens over time. So when there's nothing to be gained by, you know, no differential outcome, what you get is sort of generally extended matching. You avoid all these problems, and the animal just says, well, I just generally go left. You get extended matching and not what I might call local matching. Local matching is what happens just after the reinforcer. They just extend, and Boutros et al. Showed that in 2009. Okay, well, I'm just going to move on slightly. So, what happens then when you simulate preference pulses? I mean, to me now, simulating a preference pulse means changing the reinforcer ratio just after a reinforcer. so that the reinforcer itself signals something that's going to be happening. See Cowie, Davison and Elif's poster. In this experiment, it was kind of like a concurrent VI schedule, but after each food delivery, there was a probability of 0.5 that a schedule is going to be available on one of the two alternatives. So it's either available on the left or it's available on the right. They're not both available. You can only get one reinforcer, right? You can only get it either left or right, but you don't know which you can get it on. So here's a baseline condition. Both were VI 27 seconds, so it might be VI 27 on the left, it might be VI 27 on the right, and you don't know. And you're not getting any preference pulses. There's no changeover delay in this. There's no preference pulses, absolutely nothing. What they do is just say, oh, well, this is what it is. And you could probably say, oh, look, we've got a bit of a preference pulse there. That's the replication of that one. But that may be because of the condition 2 that went in between there. So there's no preference pulse when there's no differential contingencies after a reinforcer. The same sort of thing will be shown by Davison, Ma and Elif later this year. Again, concurrent VI with no changeover delay. And we're getting no preference pulses whatsoever in this whole thing. Absolutely none. You might say there, but they're both going the same direction, so you probably wouldn't want to say that. Notice, though, that the preferences go up and down perfectly well with different probabilities of reinforcement, 0.1, 0.9 on the left, 0.1 on the left. And so you're getting matching. No trouble about matching. You're just not getting preference pulses. You probably don't need preference pulses for matching. They're probably irrelevant to the whole thing, which is kind of interesting because if you get them, it still matches. So, you know, you can foul around with the local stuff, you still get global matching. Which may be important. Gene Hayman showed the same sort of thing way back in 1978. So, now, this is another set of conditions from this experiment. Now, this one, we've got VI 5 seconds and we've got VI 50 seconds. Right? So what left sooner or right later means is that after a reinforcer with a probability of 0.5, it will either be a VI 5 on the left or VI 50 on the right, and you don't know which it's going to be. Okay? So what happens, as you might expect, is that the behavior is strongly to the left for a while. If that doesn't pay off, it moves across to the right. Yeah? So what the reinforcer now, at this point, this is the reinforcer, starting with the reinforcer. What this reinforcer is signaling is things change after reinforcement, and, you know, it's doing it very nicely indeed. On this one, it's left later, right sooner. So start on the right and then move across to the left at a later time. Okay, so that looks good, but you say to yourself, I'm sure someone's saying to themselves, oh, look, why are the red ones always over the green ones? Perhaps Davison is wrong about reinforcement. Perhaps that's a reinforcement effect. Well, let's just ignore that for a minute. Now, things they can't do very well. Same sooner, other later. Well, they can do it if you say, on the one you just got the reinforcer on, it will be the VI 5 or the VI 50 on the other, okay, each time. So, you know, what you want to do is to kind of stay and then move. They can't do that terribly well. They do it for a while, you know, they go on the same, or that will be going on the same as well there, and then they sort of go, ooh, can't do it anymore. Same later, other sooner, they get into real strife with that. So that it's the VI 50 when you get a reinforcement on the left, then it's likely to be the VI 50 on the left or the VI 5 seconds on the right. Vice versa on the other key. They found it quite difficult to do that. And there's another replication of same later, other sooner down here. You'll notice really that, you know, these axes are quite long, and that's because I'm about to show you some much bigger pulses that occur. And here are some of them. And that you've seen already. That's the same later, other sooner. Right? So it's likely to occur later on the one you've just got the reinforcer on, or sooner on the other one. And they're not very good at that. But if you remind them, as it were, about which reinforcer you just got by putting up a stimulus on the key that shows which reinforcer you just got, suddenly everything becomes very, very clear. Okay, so if you go left reinforcer, you go right and then left. If you get a right reinforcer, you go left and then right. These are exactly the same contingencies, except we've got a stimulus coming in here that says this is the reinforcer you just got. So the control by which one did you just get is usually pretty awful, but you can make it a lot better by telling the animal which one you just got. So that stimulus there is a bit like having written it down or remembering it or something like that. If they can remember it, they get it really nicely right. But this kind of thing, left later, right sooner, they could do perfectly well. They do left-right extremely well. So that was good, and when we put the signal in, it didn't change anything at all, because they can remember left and right particularly well, but not which one was the last one so well. Now, is there a reinforcement effect? If there is, it's very, very small. Notice these two here. Well, you know, the red is above the green, which says they are more likely to do what they just got. Okay, the green is on the right, the red is on the left. There's something there that says there might be a reinforcement effect. I might be wrong about there being no reinforcement effect, no picking up of the response that it just emitted. Well, if there is, it's going to be very small. It might be just stay on the same alternative. That's another possibility. But it might be something else. If the animal fails to detect the signals or the consequences, what follows the reinforcer of the signal, if future contingencies are not differential or not detectable, or if the signaling stimuli are not differentiable, then maybe you're just more likely to repeat what you last did. So maybe reinforcement comes out when you really can't tell what the reinforcers are signaling. All you can do is just, well, let's do the last thing. That's probably a good rule of thumb. Well, I don't think so. There's three conditions in which those two problems would have occurred for the animal, and in each of those three conditions there was no obvious reinforcement effect. Maybe a tiny little bit here. Okay, nothing here, and this one is in the wrong direction anyway. 5 minutes. So, what I'm really saying is that I think I'll have to avoid this one. This is a complicated one, but it basically says that the time to the last reinforcer can also control the choice following that reinforcer. Okay, so there's another set of discriminative controls here. So, post-reinforcer preference pulses are dynamic. They are produced by the organism quite often. And if you have no changeover delay, you don't get a preference pulse because there's no food differential after the reinforcer unless you came with a preference at that point and forced it. Right? So it implies that there is no real local reinforcement effect. You do get preference pulses after foods if you have a changeover delay, if you have a period of time where you can't get reinforcement on the other alternative. So it looks like a reinforcer effect, but this is just an effect that is caused by the changeover delay. You have got a real contingency going on there just after the reinforcer. So, as I said, preference pulses are not important to matching. So what I'm wanting to say is that, and you know, I have to thank Tim Shahan for this, is something like discriminative stimuli, reinforcers as discriminative stimuli. You can get sequences effects, you know, left, 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 and things like that. That sort of heightens the control by that particular discriminative stimulus, and that will, you know, change behaviour, as you saw in the right at the start. all these things, all the things that go around a reinforcer, the time to it, which one it was, things like that, what its consequences are, how discriminable two reinforcers are, all those things matter when you're thinking about reinforcers as discriminative stimuli. And it was Tim who said this, he said, well, I'm saying behavior follows the signposts. If they can be discriminated, and if you're interested in going somewhere, then you follow the signposts. And just before coming here, I thought signposts were too static. I mean, it's more like weather forecasts. But it's not even like weather forecasts, because weather forecasts are, you can't do anything about the weather. But here, the animals can do something about the weather. If they show a big preference, they will get the reinforcers where they show the preference to. So it's much more dynamical than the weather. I wish the weather was like that. So, the bottom line to all this kind of thing is, if you want to change the frequency of behavior, you've got to think of what your reinforcers, your organismically valuable activities are signaling. Beyond that point, you've got to make absolutely sure that they don't predict a worse future. And I think I've seen in many kind of applied situations in which I think it does imply a worse future. Like, reliably do 10 trials and then move on to make the conditions more difficult or something like that. What's happening here is that you're setting up something that says those reinforcers are implying in the future that things are going to get really bad. Be consistent across sessions. Don't teach them that things are going to get worse when you've mastered the current task. A whole bunch of things like this. It's a different way of thinking about reinforcements. What I'm saying here is that all these things about reinforcement are not epicycles to reinforcement. They are what reinforcement does. If you turn the whole thing on its head and say all these things, the stimulus properties are what reinforcement does. Every half-decent practitioner, in fact, knows all these problems that they can get into. But they have always thought of them as epicycles and not as the real thing. Finally, and this just dropping right in the end here, this approach brings us close, in fact maybe you might think too close, to the associative conditioners. Because this is what they've been saying for many, many years. And I think that we may have just got it wrong and backwards and upside down. And I think that if we start thinking in these terms, we'll get a lot further and have a lot more understanding and have a better applied science of behavior.